Okay, so I'm finally going to launch the long anticipated online robot program, building program. And what I have here is basically the raw parts that we'll be using in this very first program. And it should, in fact, or will, allow us to build something much more complex and cool like this robot here, which we can use for a number of different competitions, events, and just fun. The way it's set up right there, it can do line following, it can do sumo battling. We can use it for navigation. It'll have sensors that can look for light and dark, and of course the ultrasonic range finders. Lots of stuff, and then an enormous number of projects on the way to getting to the robot. But we start off with a pile of parts like this, and this basic kit design that I've chosen uses two DC motors like these, okay, and a plexiglass chassis, all right, which ultimately, when everything's said and done, we'll end up building a robot chassis like the one here. Okay, very simple. The only thing that's a bit odd about it is, even though the DC motors are really affordable, they're actually a touch more difficult to control than servo motors. And as we move through things, we'll talk about servo motors and various options of control. And of course, I have other videos that we can use to launch to various other projects. But the basic chassis is going to be this DC motor. I want to show you. Let's go to the web here real quick. The processor I want to use, let me zoom this back down again just for a moment. I'm going to base everything upon this Teensy 3.1 Arduino compatible controller. Okay? And what I love about this little device is, first off, it's little. You just saw how small it was. And it's enormously packed with all kinds of resources. You can see here it has a number of I/O ways of getting in and out of the processor. All of these over here are analog, so it can actually look at, using a sensor, the actual lightness and darkness of an object, or we can measure the actual distance to something in centimeters or inches or whatever. We can measure temperature as a real value. All of these are strictly digital. By the way, these can be digital as well. Basically digital meaning on and off, but we can actually do an amazing amount of smart stuff with that, because I can pulse things at different rates. I can have the number of pulses per second correspond to, for example, how far something is away. So we're going to use this particular chip, which is, again, like I said, about 100%. There's subtle differences, but it's about 100% compatible with Arduino, which means that we'll be using software that looks like this and writing code that is of a C-type derived language. The other resources that'll be available is, you actually don't have to do an online class. You don't have to be live with me, although I'll be live at least twice a week, and we'll schedule times for that. But I also have video tutorials, and if you go to the Teensy breadboard bot and click on that, you'll see that I already have posted about 20 videos which are step-by-step instructions on assembly and code, including some homework assignments in here to challenge you to do a variety of things. So what you'll end up doing is you'll get this kit and you'll be following along primarily with the online videos. What we'll end up doing is, like I said, once or twice a week, I will be available. If you're having any issues or problems or questions, we can talk about it then. And we'll also try to find times, if you're in the area, if we're local to each other, or any groups that are local to each other, we'll find a time to try to help schedule an event where we can do things like do a line following competition. I have some of that information up here in the pitch if you want to listen to that particular video or see that particular video. Going back to the kit, it's going to have, at the minimum, and in fact I might just, occasionally I come up with a cool idea and I just throw in a couple parts. It's going to have things like this tricolor LED, okay, red, green, blue, flash it fast enough, it looks white. A number of regular LEDs we can use, for example, as a bar graph or something else. The ultrasonic transducer, transmit and receive. This is what we can use to echo and find how far we are away from an object. Oddly, this is actually not an analog sensor. This is digital. This is going to be one that pulses a number of times per second, depending on the distance. We have these little encoders in this package we might get around to using to see how fast a particular motor is going. They have motor driver chips. These are called L293Ds. They can drive 2 DC motors at low current. We have infrared LEDs and capacitors and filters, and we'll be making, there's photoresistors in here as well that we can use to measure light. And we'll be putting all these individual parts together to make a variety of different sensors. And of course all the cabling is here, USB cables, battery packs, and last but not least a breadboard which we're going to be using to construct all the different projects. So the only thing you're going to need that this kit does not include is a wire cutter and a wire stripper, or one of, there are devices that do both. Batteries, okay, and we don't even need batteries initially because it'll run off the USB until we start driving motors. And for the last step is you don't need a soldering iron. A soldering iron would be nice, but it's not necessary, because I actually, when I built these sensors here, I did not use a soldering iron. I twisted the wires together, but what is needed is a hot glue gun. Okay, that's what actually ended up insulating all the individual wires. But again, a soldering iron would be preferred, but it's not required. So I think that basically introduces what it is I want to talk about and the basic kit. And hopefully I will see you soon. Bye.